Hello, my name is Kays and welcome to another episode of Kays Labs. So what did the cat drag in today? Well, it's an Akai AX60. I'm really excited to have found this keyboard. It's a relatively rare synth from 1986. It's a 6-voice synth. It's got some really interesting filtering option, really interesting LFOs, and most importantly, it has all these cool little levers so you can kind of do some real-time control as you play the keyboard. There's a funny story about how I came to be in possession of this keyboard. I bought it from this gentleman on Reverb who sold it to me for a really nice price. And he told me like the keyboard works, it's just that it's in really bad shape, so like aesthetically it looks like a mess. I bought it, paid for it, he shipped it out to me, and lo and behold, I received the package a few days later in the mail, and when I opened the package, it was full of shoes, if you can believe that. And I immediately got alarmed. I contacted him, and for the longest time it appeared that the shipment company had messed up the addresses and sent me someone else's package, and then who knows where the synth would have ended up. And we were both really bummed out by it, especially because it is a piece of history and it kind of stinks if it went lost God knows where. And then lo and behold, about a week later, I opened the door and there's this big box in front of it, and sure enough, the synth had arrived. So whatever happened with the shipment company, they figured it out and they finally were able to send me the synthesizer. And yes, I still do have the box of shoes that I don't really know what to do with. A word of warning, as always, if you're not feeling comfortable operating around electrical systems, electrical circuits, and so on, and you're following along, you might want to seek the help of a professional before you hurt yourself, because there's a lot of power going in here, there's live electricity, and if you're not absolutely 100% comfortable operating around these types of circuits, it's best that you let somebody else do it. Without further ado, let's dig in the Akai AX60 and see what we will be doing. Alright, so here we have the Akai AX60, and as I mentioned, it does turn on and it makes sound, which is fantastic. The keyboard, for the most part, appears to be working, except for this C right here, which is not playing. I think it's probably like a dirty sensor or something like that. And then, of course, somebody put out a cigarette on this plastic key right here, which looks awful. Anyway, this entire keyboard needs some serious TLC. You can see like all the keys are really wobbly and loose. So I'm gonna have to like really take a look and see how I can fix this and make it look a lot nicer. On top of the front panel, I mean, there's like scratches here. I mean, whoever owned this thing before gigged pretty hard with it. The buttons for the most part work, but like they're kind of like a little bit funky, so I'm probably going to replace the switches underneath the buttons. And regarding the sliders, there's this Australian engineer named GOLT. I'll put a link to his YouTube channel in the description for this video, and he's made like a really cool modification where like he's removed all of these sliders and put these cool little sliders with LED lights, and I think it looks so cool, and I really want to do the same thing. So what I'm going to do is like desolder all of these sliders and then replace them with the LED ones, which I think is going to make it look really slick. If you look carefully right here, like some of these little light covers, I guess, they've come unglued, so I'm probably gonna have to glue them back in. And aside from that, the other thing that is really bugging me about this particular unit is if we look in the back, this is the power cable, and as you can see, it's attached right into the unit, so it's coming right from the inside, and you can't kind of like just kind of unplug it and plug it back in as needed. So what I like to do is I like to replace it with one of these guys. I like to put this guy in here. It's going to require a little bit of cutting the metal, but I think I can do it with a Dremel tool, and I think it's just going to be so much nicer because then I can use one of those standard type of power cords. So that's gonna be it on the outside. Now let's take a look inside and see what else we can find. All right, so here is the interior of the Akai AX60. It's really easy to access it. There's a couple of screws on the top right, a couple of screws on the top left. I think there's about like 4 screws on the rear that need to come out, and then the whole thing flips open. And this is such a nicer design over, say, like the Korg DW series, where you have a million screws on the bottom of the unit that you have to like flip it open. Like, it's just, oh my God, it's such a mess. This is much, much nicer in order to be able to access the interior of the unit. Now, looking at circuit boards, at least doing a visual inspection, everything seems to be okay. I mean, it's filthy as hell, it reeks like smoke, but in general, the circuit boards look in pretty decent shape, so I'm kind of keeping my fingers crossed that all of the components work fine. One of the things that I would like to do is update the power supply with a new design that GOLT has kindly provided to the internet. And what he does is like he provides the Eagle files that you can then upload to one of those like PCB manufacturing companies, and that's exactly what I did. I got this PCB made, and I'm just kind of filling it in with all of the components that it needs. I don't have all of the components quite yet. I'm waiting for a couple of things to arrive, but once this is finished, it should be pretty much like an easy like a drop-in replacement for this power supply. Now, as you saw, the power supply works fine. It's just that this new design provides a much cleaner, much more stable power to the rest of the circuits. So I think this is like a good update for this Akai AX60. The other thing that I would like to do is, you can see here, there's the memory battery that is like soldered onto the PCB, and I'd like to replace it with like a little battery holder so that in the future I can kind of swap out the memory battery much more easily. And the other thing I need to do is obviously remove these circuit boards from the top so that I can kind of access the sliders and the button switches underneath, so I can kind of replace them all with the LED ones. I'm going to need to take this guy out and remove the keyboard, and that's going to give me access to all of the sensors underneath that I can kind of clean thoroughly and see if I can get this C working again. And beyond that, I'm hoping that maybe I can kind of like find a way to get these keys to be a little less wobbly, because I'm really hating how loose the keyboard feels. So looks like I have a pretty good strategy moving forward, but I think the very first thing I'm going to do is put in that socket for the power cord so that I don't have to worry about dealing with this weird shoddy looking power cord that's already attached to the unit. All right, so first thing is done. I was able with a Dremel tool to cut out a larger hole from the back of the chassis so that I could kind of fit this standard power socket. So now I can just kind of plug and unplug standard power cables as much as I want. Now, one of the things that I was going to point out, actually 2 things that I was going to point out. First of all, be real careful with the Dremel. You can probably see that it's slipped in a couple of places and kind of scraped out the paint. So I'm probably just going to have to like retouch it a little bit just to kind of hide my messiness. But the other most important thing that I was going to point out is if we open up the top cover, you can see right here, hopefully you can kind of see it on camera, is that there's this little piece of metal that I marked in silver right now that is actually getting in the way of the plastic socket. So when you close it, it actually kind of sort of like bumps up against this one. In retrospect, what I should have done is probably like just put the socket just a little bit lower and this wouldn't be a problem. But instead, what I'm going to have to do now is cut out this little metal piece right here so that I can close the top cover and it won't interfere with the new power socket. The next thing that I would like to do is basically remove the entirety of all of the PCBs inside so I can kind of give it a thorough clean, and also on those top PCBs I can kind of start desoldering the sliders and the button switches so I can kind of replace them. Now, one of the things that I always say in my videos, and I am going to remind you in this one, is to always take careful photos, be very meticulous, just document everything, because the thing that you don't want it to happen is that you start unplugging everything, take everything out, and the next thing you know is like when you put it back together, you're not quite sure where everything goes. And I think I'm gonna go one step further. I'm just gonna put like little labels on each one of these bundles so that I know exactly where they're supposed to go, because you know, a lot of them are the same exact size, and the last thing that you want it to happen is that you're unplugging everything, clean everything out, and then you go to put everything back together and you're not quite sure, does this go in here, does it go in here, does it go in here, and it can be a real mess. So always take photos and document, and ideally put little labels on the cables so that you know exactly where they're supposed to go back. Without further ado, let's start taking everything out. All right, so here are all the PCBs from the AX60. You got like the two main control boards that fit on the top portion of the unit. Then you have the processing PCB, the voice PCB, and I believe this is the analog chorus PCB. And I was able to kind of keep at least these two guys like hooked up to each other, so I don't have to worry about like unplugging, labeling, and plugging stuff back in. But the ones that I did have to unplug, I did put like a little label so I know exactly where they go back to. So there's a couple of things I want to do. Like, first of all, I do want to replace this battery, which is probably old and needs to be replaced anyway. But I want to put like a nice little battery holder in there that's going to make replacing this battery in the future much easier. And then the other big part of the job is going to be to take out all of these little switches and the sliders and replace them. The switches definitely, because you know, some of them like just acting like a little funky. So I'm just gonna put like brand new switches. And the sliders, I have the new LED sliders coming in the mail in a couple of days. So that's gonna be really sweet when it's all in place. The only two sliders that I'm not touching, however, are these two. One is the volume, and the other one, I think, is like the split level slider. And the reason why is because those are two very specific sliders. I think this is like a 2-track slider, and this has a center detent, and it's basically like one slider here and one slider here. And those are not available as LED sliders. So I'm just gonna leave the original ones, probably just kind of clean it up a little bit, but they should be fine. The other thing that I have to do is clean up the top portion of the keyboard. I took out all the little clear plastic covers from here so I can kind of give it a nice thorough clean. I might kind of buff it a little bit, see if I can kind of make it a little more shiny. There's scratches and stuff like that that I just don't think I can do a whole lot about, but you know, it is what it is. And then last but not least, it's going to be like the main chassis. I'm going to have to remove the keyboard, the pitch wheels, give the chassis a whole thorough clean, and then I'm going to be dealing with the keyboard as the last thing, which, as I said, this keyboard needs some TLC for sure. But anyway, first things first, let's get going with desoldering all of the buttons and the sliders. Alright, so I went ahead and desoldered all of the sliders and all of the buttons from the top two control boards, and I gave them a nice clean, so now it's nice and shiny, and hopefully it's going to help get rid of this horrible smoke smell that this entire synthesizer seems to have. Now, I don't have the LED sliders yet. They're coming in the mail. They should be arriving here in a couple of days, but I don't have those quite yet. So what I thought I would do is get started maybe in soldering back the buttons, which I do have. But before I do so, I wanted to bring something up to your attention because this can be a little confusing about these particular buttons. So this is what came off of the AX60. Those are fairly standard 6mm by 6mm square buttons. Those are tactile switches, I guess I should say, instead of buttons. But anyway, so this is what came off of the keyboard. Now, what I went ahead and ordered here, let me see if I can kind of show you, is two different types of buttons. And hopefully you're going to be able to see some of the difference between the two of them. Okay, so these two guys look very similar, but they're actually not exactly the same. So the one on the left is a 4.3mm high button, and the one on the right, if you can tell, is slightly taller, even though they're like not lined up. Sorry, this is the best that I can do. So the one on the right is actually 5mm high, and the buttons that came from the AX60 are 5mm high as well. So I just went ahead and ordered two different types just to cover all my bases just in case. So these are the ones that I got from Taida for the 4.3mm high. And here are the ones that I got also from Taida, which are 6x6 by 5mm high. So if you're going to replace the buttons on the AX60, make sure that you get the right height, which, as I said, is 5mm. Well, that took a while, but I think I took care of all the switches, so all of these are brand new. I hope I didn't forget any because there's a whole lot of them. And while I was at it, I also put in a brand new battery holder in here and with a brand new battery, just in case. So now I am waiting for the LED sliders. As I said, they should be getting here in a couple of days. And rather than show you the detail of putting all those guys in, I'm going to rather like post a link for GOLT's excellent video, because he goes into really a great deal of detail on how to put in the sliders and how to wire them up. And maybe after I've set them all up, I'm going to like do a little recap on exactly what I did, just in case something is not completely clear quite yet. But as I said, right now I'm just waiting for these LED sliders to arrive. So see you in a couple of days. And the LED sliders have finally arrived from Mouser. I'm going to post the part number on the screen that you should be seeing right now. And that way you know exactly how to order the same exact ones if you want to. They were a little pricey. I think for about 20 of them, it came out to about like $45. I mean, it's not terrible, but I think it's a nice upgrade to this keyboard. So I'm glad I'm I'm glad I did it. I think it's worth it. There were a couple of small modifications that need to happen to the sliders themselves. Once again, I refer to you the GOLT video because he goes into a great deal of detail and explains exactly what needs to happen and why. But basically, you have to put like this little loop here that you have to like solder in. I don't know if you can kind of see it. You have to strain out the two end pins. Those are for like the LED power. And last but not least, you have to like kind of like bend out the little legs on the bottom because they come in and they're like bent inwards, if you can see, and you just have like to kind of straighten them out so that they fit in the PCB. But aside from that, it's pretty straightforward. So anyway, I'm gonna post a link to the GOLT video. That's the one that you should be watching to install these guys, and it will tell you everything you need to know. And then I'll come back and kind of show you my end result. All right, so the LED sliders have been soldered back onto the PCB and wired up. I know this looks crazy complicated, but don't worry, I'm gonna go through it before I put this board back into the synthesizer and explain exactly what all the connections are. Having said that, I'm not quite ready to do that yet. I am waiting for a couple components to arrive. So I'm just gonna put this aside for a bit and turn my attention to the keyboard, which is in really bad shape. I mean, it's filthy. The keys are like, have this like kind of weird, like sideways sort of looseness that I want to see if I can do something about. And there's this nasty cigarette burn mark that I really hate looking at. I want to see if I can at very least like sand it down and kind of smooth it out a bit so it doesn't look quite so unsightly. And last but not least, I seem to remember that this C key was not triggering, so I'm gonna have to look at the sensor underneath and see if something is wrong with it. So the first thing I need to do is start removing the keys one by one, as I always do, so I can give them a nice wash, and I'm probably gonna buff them. And yes, I'm thinking about putting weights underneath the keys, like I've done for the Korg DW6000 and the Oberheim Matrix 6. Just because of the fact that I think it can help the keyboard feel a little less plasticky. At any rate, let's get to work on the keyboard. All right, so removing the keys on the AX60 is fairly straightforward, much like the DW6000. You just kind of push down and then gently kind of pry these two little plastic sides until the key slides off, and then from that point you can just kind of remove it. There's a little spring at the tail end of it that you can just kind of take out, and I'm just going to put them all together. They should all be the same exact spring. But yeah, I mean, this looks reasonably similar to the DW6000 key. Now, one of the things that I was looking at is that, as I said, all the keys have this kind of really annoying sideways looseness, and I like to fix it somehow. And from what I can tell, let's see if I can kind of show you, there's these little metal tabs on this end that are supposed to kind of prevent some of this like kind of sideways movement. And some of them have a little bit of like this kind of little piece of rubber around it, this rubber ring. And I think that helps, but most of them don't. And because of that, I don't know if you can kind of see, like some of them have even like kind of created a little bit of grooves underneath. So I think, you know, from using them and kind of going up and down so many times, eventually like the bare metal has kind of like rubbed off some of the plastic, making them even more loose. So I want to see if maybe I might be able to create a little bit of these kind of like rubberized rings to kind of put around each of these tabs, and hopefully that's going to help with this sideways motion that is really ugly and annoying. So I'm gonna have to think about it and see if I can come up with a solution for this. So with all the keys removed, I can kind of take a little bit closer look at this metal key bed. And yeah, I mean, there's, as you can see, like some of these guys have these little rubber bushings and most of them don't. But also, like, I think that these rubber bushings are really thin, and they are contributing to like this kind of keys feeling very loose side to side. So I want to see if I can kind of maybe beef them up a little bit. The other thing that I'm noticing is like the felt is in really bad shape. I mean, you can see just how worn in it is, both at the bottom and the top, so I'm probably going to be replacing the felt as well. And the next thing I need to do is unscrew this bottom PCB so I can kind of take a look at the sensors and try to figure out exactly what might be happening over at the C key, which is somewhere in this area, to get a sense if it can be repaired. Okay, so all of the keys have been cleaned. I'm in the process of reinstalling the keyboard. I added these little automotive weights on the underside of the white keys here, and on the black keys I put them in this little cavity here. I think it helps. It kind of gives a little more mass, a little more weight to these plastic keys, and it just kind of makes them feel nicer to play, in my opinion. So the keyboard chassis has these little metal tabs, and on top of these metal tabs there are these little pieces of I guess like little rubber bushings. You can kind of see them here, and these rubber bushings have these teeny tiny little wings on the side. Hopefully you can kind of make them out in the video, okay? And all of them in all the cases are pointed up and down. And I started wondering, what if that is the problem? And if these guys were actually pointing side to side, maybe that would provide just enough kind of stability in between the keys so that they wouldn't have quite as much play. So that's exactly what I did. You can kind of see here, as opposed to like going up and down like this one, I put them side to side, okay? And to show you the result, this key right here has one of these bushings that are side to side, and look at this. It's barely moving. I mean, these guys feel so much more stable than they used to be. So I think that did the trick. And now all I have to do is just kind of like change the orientation, all these little teeny tiny bushings on these metal tabs. Now, I have another issue, and the other issue is that a lot of these guys are missing, okay? There's like a lot of spots here where they don't really have anything. I guess like they kind of fell off or something like that. So my solution for this is I'm gonna use a little bit of this shrink tubing, okay? And just have one that kind of feels roughly the right size. So I'm putting this guy in here. It's not quite the same as having, you know, these little wings, but I mean, I guess that's the best that I can do right now. I looked up and down to see if anybody sells replacement for these guys, and I can't really find them online. If some of you guys know where to buy them, and I believe they're like different for each and every type of keyboard, but I would love to get like proper replacements. But you know, in the meantime, I guess this is gonna have to do the trick. So I'm gonna put the keyboard back together, and then I'm ready to start reassembling the Akai AX60. So the keyboard has been fully reassembled. I cleaned out all the sensors underneath. Hopefully all the keys work now. For the most part, everything feels a lot more stable and secure. There's not as much side-to-side play. I mean, there is here and there, but for the most part, it feels much, much better than it used to be. The top cover, I have put new felts in here and cut little slits for the sliders to fit in. Unfortunately, I didn't have like black felt, so I used this dark blue one, but it should be okay. Well, would you look at that? I have power to the LEDs and they're all working as expected. So this was a bit of a brain twister for sure. And the reason why is, even though GOLT has this really, really excellent video on how to make this modification for the AX60, he doesn't really go into a great deal of detail in exactly how these sliders are wired up. And because of that, I was a little confused, and I had to do a little bit of kind of reverse engineering to try to kind of figure out, and like, there was a lot of pause and freeze frame and trying to kind of like look at his circuit so I could kind of replicate it. So I thought that I would describe to you guys exactly what I did so that if you guys are doing this to your Akai, you can replicate it, and hopefully it's going to be a little bit less confusing than it was for me. So the way things work is that GOLT opted to tap into a 15-volt rail line from the power supply. Now, this is the new power supply that GOLT designed, and the nice thing is that it actually has like an extra set of 15-volt output specifically for the LED lights, which was really, really nice for him to include. But you can tap into the original power supply as well, and I think you would just go through the positive 15-volt regulator in that case. But anyway, regardless, there's 15 volts that are coming from the power supply, and the biggest problem is that each LED normally is pretty happy with about like 2 volts, sometimes even less than that. So putting like 15 volts onto a single LED would burn it out. And what we had to do in that case is put like a resistor in line to diminish the voltage that the LED is getting so it doesn't burn out. And part of the problem is that if we're asking the resistor to go from like 15 volts down to 2, that's going to put like a lot of stress on the resistor, and it's going to create a lot of heat. And GOLT's solution to the problem was to wire groups of these LED sliders together so that in this case we have like 5 of them. Okay, so if each one of them gets like 2 volts, we have a total of 10 volts. So now all of a sudden the resistor only has to drop the voltage by about like 5 volts, which is not as bad as like 13 volts. Okay, so the way that this works is that we have the 15 volts coming from the power supply. So the yellow cable is the lead. Okay, so 15 volts is coming in here. It's going through a resistor, and then it's connecting to the first slider, the LED power little tab right there. And then on the back side, it's instead of going back to the ground, it's going to the next slider, and then to the next slider after that, and the next slider after that, and the next slider after that. And then it's ending at the ground right here. So this black cable is going back to the ground, and it's completing the circuit. So this is one circuit, which is 5 of these LED sliders combined together. And then we do the same thing over here. There's another 15-volt line that's coming in, going through another resistor. And then the first slider is wiring back up to the second, to the third, to the fourth, to the fifth, and then ending up in the ground. In this case, the ground is wired together. It's okay for the ground to be common. You just cannot have the lead to be one single lead for all of them, because otherwise we would not be having enough voltage, 15 volts for like, I think there's like 18 of these sliders, and we wouldn't have enough power for all of them. Now we have another group, but this one only has 4. Okay, so same thing, 15 volts going into a resistor, going to the first slider, then looping around to the second slider, to the third, to the fourth, and then ending up on the ground, which I don't know if you can see very clearly. And then we have one last group, once again, 15 volts coming into the first slider through a resistor. You can't see it here because I put like some shrink wrap, and then looping around to the second, to the third, and then finally to the fourth one, which is terminating with the ground. Okay, so hopefully that sheds a little bit of light on how to properly wire all these guys up. Now, the other thing that I was confused is like what value resistors to use, and GOLT doesn't tell us that in his video. And rightfully so, because depending on the type of LED slider that you get, depending on the color and some of these other factors, then your resistor is going to be different. But if you guys are going to go with these particular LED sliders, these are like Borns, I don't know how to pronounce it correctly. Anyway, those are Borns sliders with red LEDs. Then I can tell you what resistance I ended up going with, okay? So for the groups of 5 sliders, I used a 3.3K resistor, And then for the groups of 4 sliders, I use something a little bit more beefy, 4.7K resistance on these 2 groups of 4. So like 3.3 resistor on here, 3.3 resistor on here, and then 4.7 on here, and then another 4.7 right there that you can't see. In my tests, I mean, I kind of like tried different resistance values. In my test, I wanted to go a little more conservative. I think I could probably like lower the resistance if I wanted to go a little bit brighter, or you can go higher if you want them dimmer, right? So I would guess like a range of resistance that you could try if you want to go brighter. I suppose you could go down to, I don't know, maybe like 2K or even 1K maybe. And then if you want them dimmer, maybe you could go up to like 10K, something like that. But as I said, for my particular purposes, 3.3K and 4.7K hit the spot. All right, so hopefully this helps you guys that are following along, and hopefully it makes this whole process a little less confusing than it was for me just from watching the GOLT video. I think I'm ready to put everything back together into the main chassis. This is where the keyboard stands right now, and it's all still in pieces parts, so I need to put like the top cover on, screw the top circuit boards back in, screw the bottom boards back in, then I'm ready to like kind of put the keyboard in and run a test, and hopefully I didn't screw anything up. So keeping my fingers crossed here that everything's gonna work like it used to. So let's find out. So the circuit boards are back in, I hooked everything up, turn it on, and lo and behold, everything comes on, and most importantly, it's making sound, and I'm really, really happy about that. I cleaned all of the keyboard contacts very thoroughly, so now even that 1C that wasn't working before is now working. I tested all the keys, everything is great. There is, however, one thing that caught my attention, and I don't know if you guys are going to be able to hear it, but basically there is this chorus button that triggers one of 2 built-in choruses in the Akai AX60. And the problem is that if I play something, then switch the chorus, switch it again, turn it off, I can't hear any difference. So that tells me that the chorus is probably not working, because I feel like I should be able to hear a difference between the chorus being off and the chorus being on, and it sounds identical to me. So I think I need to do some research and try to figure out why the chorus is not coming on. So on the Akai AX60, the chorus circuitry is part of this smaller, I guess like daughter board, maybe you want to call it. I mean, up top we have the 2 main control boards. This is where like all the buttons and sliders are hooked up to. Then down here we have the main processing board, and below here we have the voice board. But basically all of the outputs and chorus of the AX60 goes through this particular circuit board. Now the chorus in particular is made up of a pair of 2 integrated circuits. This guy right here, which is, my understanding is like it's a processing for like chorus and delay type of processing, and this guy next to it is a clock source, and there's 2 pairs of it, which I'm assuming correspond to like chorus 1 and chorus 2. Now, my understanding is that like if one of these chips went out, it wouldn't necessarily stop both choruses from working, and I find it really hard to believe that all 4 of these ICs would have all stopped working. So I suspect that maybe the problem lies somewhere else. But the best thing for me to do right now is to take this board out, put it on the bench, and take a closer look to see if something looks obviously out of place. I removed the board from the AX60, and now I'm just kind of looking at it, and it's looking pretty decent, honestly. I mean, I'm not really seeing any signs of damage or anything like that. So I think what I'm gonna do first is take out all 4 of these ICs and put sockets in there so I can kind of maybe like swap them around and see if that does anything. I don't know. I'm a little bit skeptical that all 4 of these guys would be, not working, but I suppose that's something to try. Other than that, I could try to replace some capacitors, but I don't know. It all seems like very, very random at this point. I'm not really quite sure if that's what I should be doing, but I guess I might as well try the ICs first and see what happens. Okay, so after having put sockets into those 4 chips, the board is back into the unit. I thoroughly cleaned the pins. I tried swapping them around. I mean, it makes no difference. The chorus is just not coming on. Now, I could go crazy and literally replace all of these chips. I could replace this group of chips. I could replace all the capacitors. I could replace the op amps. And it might still not make any difference whatsoever. Because, I mean, as far as I know, maybe it could be as simple as like the switch from the chorus switch over there is just not sending the right signal here. So I think I've reached the point where this is as far as I can take it with my current tools. And I think what I need to do is basically do something that I've been kind of pushing off for the longest time, which is to buy an oscilloscope, because without an oscilloscope, trying to kind of figure out which one of these components is not working is completely moot. I'm a little bit scared of the oscilloscope. It just looks really complicated. It means I'm going to have to like watch a bunch of YouTube videos to try to kind of figure out how to diagnose chips with an oscilloscope. But at the same time, if I'm really serious about continuing to repair this vintage synth, I really need one. So I think I'm going to order one today and I'll wait for it to arrive, and then hopefully I'm going to be able to use it to try to diagnose exactly what is going on in here. All right, so here is the chorus circuit board and it has been fixed. And yes, I did end up buying myself an oscilloscope. This is like a small little portable unit, which helped me diagnose it, but in reality, I would have probably been able to kind of like fix this just with a multimeter if I would have paid a little bit closer attention to what was going on. So let me explain to you why I think a multimeter would have been just fine with this particular issue that I had here. So hopefully you'll be able to see what I was able to kind of figure out as to why the chorus was not working. Here, I'm just going to zoom in a little bit, and hopefully you can kind of see what I'm seeing, if this thing will stay in focus. So basically, I realized after a lot of like kind of trials and tribulations and just kind of like tracing all of this kind of signal path and stuff like that, I realized that there was like this really nasty scratch that kind of went across all these traces right here. I hope this is not something that I accidentally did. I don't think so. I'm like fairly careful about like moving the circuit boards around. Maybe it's something that happened in shipping. Maybe the previous owner or whoever might have done some servicing on it accidentally like kind of scratched the crap out of this circuit board. But basically, several of these traces, particularly like this this teeny tiny one right here, if you can kind of see, was completely cut off. So the signal couldn't get from this part to where it was going, which was over here. But other traces were equally cut off. So what I ended up doing is I ended up like kind of bridging them with a little bit of solder. And after I did that, everything worked just fine. So I said, like, I mean, I could have used a multimeter to test for continuity between these points where the scratch was, and that would have also given me the solution. But nonetheless, I'm happy that I got the oscilloscope. I'm going to be talking about the oscilloscope maybe in a future video. I'm still trying to kind of figure it out. I'm still honestly trying to learn how to use it. I literally just got it a couple of days ago, and I've been watching a ton of YouTube videos, trying to kind of get up to speed. But nonetheless, it was useful to help me diagnose what was going on and where exactly the signal was being cut off. So with that said, I think I'm ready to put this back into the Akai AX60, and at this point I think I got everything covered. I think I took care of everything. So, let's find out. All right, so I put the chorus circuit board back into the unit, fired it up, and let's see if the chorus works. So this is without any chorus whatsoever. Hopefully you guys can kind of hear what I'm hearing. So no chorus. Turn on chorus 1. Hopefully that's coming across in the audio. Here's chorus 2. And once again, no chorus. So hopefully you guys can hear the chorus is working. It's adding a nice little depth effect to the sound, and I think it's a nice thing to have on the synthesizer. Now, as I'm firing everything up and kind of double checking and triple checking everything, I am spotting a couple small little boogaboos that I'm probably gonna need to take a look at. The LED faders, the sliders are all working for the most part, but this guy right here and this guy right here are not lit up for some reason. So I need to investigate and try to kind of figure out if maybe like a wire has come loose or like some solder point has come loose. But these two guys should definitely be lit up like the rest of them. So let's take a look at the LEDs and see if we can figure out why these guys are not lit up like the other ones. Pulled the boards out, turned it on, and all the lights are working now. And I put them back in, and all of a sudden this light right here and this light right here are not working. And I'm like, what in the world is going on? And once again, it turns out the explanation to be something really dumb and stupid, but yet something that can cause some pretty major problems. So let me kind of show you here. Hopefully you're going to be able to see. But right here, when I was soldering, some of this little rubber casing kind of got melted out. And when I put a screw through this hole, it actually kind of shorts out the circuit and basically gets the current to stop flowing to this guy and instead starts flowing to the actual keyboard chassis. And the same thing was happening here. And in this case, I put like some electrical tape to isolate it. And I'm just going to do the same thing right here. Just kind of put a little bit of electrical tape to try to kind of keep the screw not to make the contact with this exposed part. And then all of a sudden the lights are working. Once again, a really simple fix, but something that can easily be missed if you're not careful and double check and make sure that everything is properly isolated. All right, here it is, the Akai AX60 in its full glory, and I couldn't be more thrilled in how it all came out. So let me recap a little bit of everything that was done. As you might recall, the unit came in, it was working, but it was like incredibly filthy. Most of the buttons didn't work. Some of these plastic covers had come loose and were rattling around in the cage. Some of the keys didn't work. Anyway, it was a bit of a mess. So the first thing I did is like take everything apart, remove everything, get everything nice and cleaned out. I buffed this front panel in its entirety and kind of clean it up as much as possible. And it's not perfect. There's still like some parts where like the paint is chipped off. And unfortunately, I'm not 100% sure how to fix this. But if you guys have some ideas on how to address some of these blemishes, please do let me know in the comments below, because I'm very, very curious. And if some of you knows a solution, I'm all ears. So moving on the inside of the keyboard, I started by replacing all the button switches. So now everything kind of feels nice and responsive. And I just love having responsive buttons. Thank you to GOLT for teaching me how to put these wonderful looking LED sliders. I just love the way these guys look, and it just makes everything look so much cooler in my opinion. I took the keyboard apart and polished all the keys. I added like little weights underneath that I think help it make it feel a little bit more solid, a little just, it's almost like it improves the quality of the plastic in some ways. There was like a nasty cigarette burn that I was able to sand down a little bit. I mean, it's not perfect, but I think I can live with it for the time being. And beyond that, like, you notice some of the keys had like this kind of really nasty side play, and I was able to kind of address that. Like, not all of them, but it's a lot better than it used to be. Moving on to the back of the unit, if you remember, I replaced the little power socket. It now has a standard 3-prong socket, so I can use just about any standard power cable, and it's just a lot easier and flexible, especially when I decide to move the unit around. And as some of you guys might have noticed, I also did end up replacing the cheeks with these really nice walnut cheeks. My friend Rob totally hooked me up and cut these guys down to the perfect size, and it's a great fit. And personally, I think they just look gorgeous and they make the whole keyboard look so much classier. So I really, really love the way it all looks. Alright, we made it to the end. It was a lot of fun to work on the Akai AX60, and I can't wait to show you how great the synthesizer sounds in the upcoming jam video. In the meantime, I also look forward to seeing what the cat will drag in next. Thank you so much for watching. I appreciate your support, and I look forward to seeing you again in the next video.